Alright, it's time for the solutions for the oddball function properties. And so oddball is kind of not really the name of them. Some of them are piecewise functions, some of them are just functions we haven't looked at before. We're not really going to dive too deep into them. But you basically just look at your function as it is graphed, and you identify these different properties about it. Domain is always how far left and right it goes. It goes left forever, it goes right forever. It's the possible inputs for your x values. So this one goes from negative infinity to infinity. The range is how far up and down it goes. This one goes down forever, it goes right forever. Down forever and up forever. So this one also from negative infinity to infinity. Our x-intercept or intercepts, well, that one can be figured out by extending this line, and it actually crosses over here at 11. You can also use your slope to kind of help you figure that out. So that's the point 11, 0. My y-intercept is going to be right here where it crosses my y-axis. That's the point 0, 3. Next one's asking where is it increasing, so go from left to right. Where is my function going up? Well, it's not going up anywhere at all, so there is no intervals where it's increasing. Next one's asking where it's decreasing. As you go from left to right, where is it going down? Well, we have this section over here, and then this section over here. And this middle one, it's constant, and so it is not decreasing there. So it decreases to the left of x being negative 3, and it's decreasing to the right of x being 2. And so we actually have two different intervals from negative infinity to negative 3. And then, also, make sure you put the u between your multiple intervals, also goes from 2 to positive infinity. So we got two different intervals, two different sections, and you just put the u between your two intervals. Next one's asking where is it positive? Well, it's positive until you reach your x-intercept over there at 11. So from negative infinity until you reach 11, it is positive. It is negative thereafter, so from 11 to infinity. Right? So my left-hand behavior is going to be as x goes to negative infinity, my function is going to go to, well, as we go left forever, my function just keeps going up and up and up and up without bound, so my function is going to go to positive infinity. For my right-hand behavior, I need to do as x approaches positive infinity, my function is going to approach, well, if I keep going right and right and right, the function keeps going down and down and down without bound, so it goes down to negative infinity. And that brings us to the last part, average rate of change over the interval from negative 5 to 8. When it gives you this interval here, that's describing the x values. So there's an x value of negative 5, there's an x value of 8. So between here and here, what's my average rate of change? Well, that goes from this point to this point over here. You need to get your rise over your run for the line that goes between, that goes through those 2 points there. And that's just a rise of negative 5 and a run of 13. So down 5, right 13. So that's going to be my average rate of change on the interval from negative 5 to 8. So there's my first one. Second one, the function goes left and right forever without any obstacles, so from negative infinity to infinity. The range, you have to look how far down it goes. Well, this one only goes down until negative 4, and it goes up from there, so from negative 4 to infinity. And this one actually includes negative 4, because that is an actual y value that you get. So I'm going to have a square bracket on negative 4. This one has multiple x-intercepts because it crosses over here and right there. So you just write them both down. Negative 1, 0. That's kind of not pleasant to look at. Negative 1, 0. And also the point 7, 0. It only has one y-intercept, which is right there. That's the point 0, negative 1. It's asking for the interval where it's increasing, meaning as you go from left to right. Where is it going up? Well, it starts going up right here at 3 and continues on to the right. And so from 3 to infinity is where it's increasing. And before you get there, is decreasing everywhere, so from negative infinity until 3. My function is positive, meaning above my x-axis, on 2 different parts. And that first part stops at -1, and the second part starts at 7. So this one actually has 2 intervals from negative infinity until -1. And, put the u there, and from 7 to infinity. And then we have to figure out where it's negative, meaning below my x-axis, and that's this section here in the middle. That goes from -1 until you reach 7. So from -1 to 7. Again, it's not negative at -1 or at 7, so we're going to have open brackets of those. For my left-hand behavior, always start out as x goes to negative infinity. My function is going to keep going up and up and up, and without bound, just keep increasing, so it's going to go to positive infinity. And as my x goes to positive infinity, as I go right forever, my function also keeps going up and up and up without bound, so my function approaches positive infinity as well on that side. And that's fine, that's the same on both sides. We need to get the average rate of change over the interval from -2 to 5. -2 is there, 5 is over here, and so these are our 2 points we're dealing with, 5, and this is where x is -2. So this is the point -2, 1. And over here we have the point 5, -2. So the change in y, my rise, is going to be -3 because it has to go down 3. And then my run is going to be 7 because you have to go 7 to get over to 5 from -2. And that's my average rate of change. So that one. Moving on to 3. This guy looks a little bit different, a little bit funky here. But domain rate, these features are going to end up being very, very similar anyway, even though it looks different. Your domain, how far left and right it goes, what are my possible values for my x? Well, that can be any number, because it does continue on right and left forever. So negative infinity to infinity. My range is also going to be the same thing, because my function goes down forever. Not in the middle, but on the left side it just keeps going down. And on the right side it keeps going up, even though in the middle it does have a maximum value of 2 there. We have multiple x-intercepts at 3 different spots, and that's just where it crosses the x-axis, which is fine. You can have the point -2, 0, the point 0, 0, and the point 3, 0. So we got 3 x-intercepts. Our y-intercept is only going to be 1, and it's right there, right where it crosses my y-axis, and that's the point 0, 0. We need to get the intervals where it's going up, increasing from left to right. Well, it's increasing up until you reach this here, and then it starts increasing again once you reach there. So from negative infinity until you reach -1, and then from 2 onward it's going up. So those are going to be my intervals, negative infinity, -1, and also 2 to positive infinity. And my function is decreasing right here in the middle, so that's just the interval from -1 to 2. The next one is asking where is it positive. Well, there's actually a couple of sections right here. So positive is where it's above my x-axis. So I got this interval here, and then I got this interval here on the right side. It's going to be up above my x-axis, and so that's what I'm going to be writing down. There's 2 intervals. This one goes from -2 to 0. And that one you're not going to include -2 or 0 because it's 0 at those points. And it also picks up again at 3, and that goes forever to the right. So those are my 2 intervals. It's negative, as in below my x-axis, over here on the left side, and in this middle section. And those intervals are just going to be from negative infinity until you reach -2, and also from 0 to 3. And then we got left end behavior. As x approaches negative infinity, my function is going to approach. Well, if you could keep going left forever, the function keeps going down forever. So that's going to be my left end behavior. As x approaches positive infinity, my function keeps going up and up and up. So my function is going to go to positive infinity. And we need to get the rate of change over the interval from -1 to 0. And so we really just have these 2 points here. And that's a rise of -2 and a run of 1. So -2/1 is going to be my average rate of change. And that's going to be the first three.